I'm very appreciative that came here to attend Linaro Connect again. 7 years before, I came to Thailand to attend Linaro Connect. I think it's a lot of things changed. 7 years before, the ARM server is poor. Sorry for ARM, right? And when two sockets connect for ARM server, it doesn't work for most of the server. But now you can see ARM server has taken a lot of some kind of market share, especially in China. If I remember correctly, last year ARM server has taken around over 10% of market share for whole volume. It's a huge number, right? So I think it has a lot of things has happened during the latest 7 years. But now, today, I want to give another kind of session. We name it Boost ARM Ecosystem with openEuler, ushering in a future of digital intelligence. So how openEuler can help ARM to expand the ecosystem and boost the intelligence, digital intelligence. Okay, first of all, I want to mention again and again and again, openEuler is an open source project incubated and operated by the Open Atom Foundation. So it's a totally a foundation project, and a lot of companies get involved the project. And here, in the later, I will explain how many companies get involved. Here you are. Okay, so in the right, you can see in last year, openEuler has taken around 37% market share in Chinese market. I only calculate the server market because for the embedded and the edge, we have no way to get the number because most of the company, they use openEuler or use the OS, but they never notify us. So for the server, we have taken around 1/3 of the market share. It's the biggest market share in China for all of the OS, including Windows, Red Hat, SUSE, Ubuntu, and a lot of kind of together. So we are the #1. So it grows very fast. And for openEuler, it has been grows up to be a very big, very huge community. So on the left, you can see some numbers. You can see we have over 1,500 enterprise members. So they have signed the CRA and joined to the openEuler, including a lot of famous companies like Intel, of course ARM, and Marvell, and Linaro, of course. And for Intel is also the golden member of openEuler. Of course, we hope Linaro and ARM also can be the member, the council member of openEuler. And we have accumulated over 18,000 contributors in the community. Every day, as we calculate, over 400 active developers per day. So it's a huge number. Of course, in the beginning, the first year, every day, the active developer is only around 150. But now, every day, there are over 4,000 developers actively develop in the community. So here globally, we have calculated over 2.3 million IP has ever downloaded openEuler. Of course, no matter how many times you download, but we count one IP, so it spread all over the world. So the whole community is very huge. openEuler is, for the industry, openEuler is a commercial community. What we do is, the commercial level product or community product, and we have used in a lot of important area, for example, the finance, career, internet, manufacturing, education, or something like that. So it has go into almost everywhere of the industry, at least in China. So we have achieved a lot of achievement during the last 4 years. So why so fast, and what we have done for openEuler to grow so fast? Generally speaking, I think we have two ways. The first way is the collaboration. The second is innovation. So let's mention collaboration first. Here is a kind of way of openEuler collaboration with different partners, or we can call it a business model. So on the bottom, openEuler will have the community distribution. We have the long-term support version for the community. And on top of the community distribution, we have developed a lot of commercial distributions, partners. In China, we have KirinSoft, UniTechSoft, KirinSac, Xfusion, a lot of this kind of OS vendor. The OS vendor will base on community distribution to release their commercial product. Then they sell their product in the market. So that's the first layer. For the second layer is we have developed a lot of openEuler service partner. We call it OESP. So if you are a company, I want to use open source, but I don't want to buy the license because license sometimes for some of the companies very expensive. They cannot afford to so expensive money. But when after they use open source, it's free. They need a service. So in China, we have a lot of companies which will do this kind of business. So you can use the open source community version, and you can find some service partner to do the service. So you can save maybe 70% of cost. And on top of that is enterprises distribution. What does it mean? So I don't do this kind of business. I don't do the OS business. And I have a very strong technology background. I can use open source and maintain it. Most of the internet companies, especially the big internet companies, they will use this way. And also some big IT companies, they also adopt this way. For example, the CT OS and the H3C and the Chinese mobile, or even Baidu. So they adopt this way. They don't need to pay any money for community or for the partner or for the service vendor. So based on this kind of collaboration way, we cover most of the customers' commercial requirements overall. So I think that is the way why openEuler has grown so fast. Every customer, they can based on their cost and the requirement to find the suitable way to collaborate. Okay, of course, except besides the business model, the most important thing for openEuler, of course, we are operating system. It's high tech, so innovation is very, very important. I think we have three technical features or labels of openEuler. The first one is all scenarios. The second one is diversifying field computing, and the third one is, of course, AI. For all scenarios, here is the architecture of openEuler. So a misunderstanding of openEuler is a lot of people think openEuler is a OS. Actually, it's no. openEuler is not a OS. Actually, it's a kind of a composing system. If you get familiar with Yocto, it's a little bit similar with Yocto, but the idea is different. For example, here is we have a package pool, or we call the component pool. We have developed a tool system which we call the Euler Maker. And then you can use the Euler Maker to make any kind of OS out of the package pool. So we have, on the website, on the portal, you can see we have three kind of reference platform. The first one is embedded OS. It's around 50 megabyte size. And for the Edge OS, we have provided a reference platform which is 500 megabyte. And for the server cloud, it's a total all. Generally speaking, if you install them all for the server, it's now the latest version is 19 gigabyte. It's very huge. But of course, you can customize or make your OS from 50 megabyte or even 5 megabyte to 19 gigabyte. So you can do the range, any OS among the range. So that is the idea. So openEuler is an OS platform that allows OS creation from different scenarios. So when we talk about the all scenario, it means you can create OS for different scenario. So I think this idea is very meet the requirement of the ARM and the linear, because ARM is from embedded to edge to server and cloud. So it's also all scenario architecture. So the design of openEuler, I think, is very match the ARM system very well. So we also encourage different partner to can use this to do the job. Okay, here is a little bit of details of what EulerMaker is, and I don't explain the details. Until now, we are still using the Yocto and the OBS as well, but by the end of this year, we will replace them all to EulerMaker. Here we can see here EulerMaker will have the customized layer, and we have the package build, and the third step is the image build. So you can define different layers, customization, and then create the package, and then from package to an image. So here is a whole DevOps process. Here is an example. I think one of the important feature is we don't use spec. We try to don't use spec to describe the package or the component anymore, because if you using the software, most of the Linux system, you use RPM or DEB. RPM use spec, but the spec has the problem. It's very difficult to handle by the computer. You have to do a lot of job to disassemble the session, the part of the system. It's very difficult. So nowadays the new design, we use YAML to describe everything. Describe the package, describe the layer, describe the image, and everything describe the YAML. So from the in the picture, the left is the traditional spec file, and on the right you can see we have extended to be the YAML. And of course we provide some tools to transfer from spec to YAML. And then here is the base OS. Here the customization part. So for EulerMaker, we have make a lot of component. We have prepared some component, including the base OS part. So you can, of course, you can make your component or define your layer, and then you can use those kind of preset component and base OS to create your system. So every file here listed is a YAML file. Okay, here is you can use on the bottom. You can use we have prepared base OS YAML system, and plus on your BSP, chipset 1, chipset 2, the layer, and then on top of that you can set up the scenario layer. For example, since the cloud native or the embedded or some features on top of that, and then you can DIY your OS. So that is the general process. So here we can see the designer of EulerMaker make a name DIY OS like a logo. We can use like logo structure. Here is I think all scenario, and then we can move to the diversified computing. On the bottom we can see openEuler. We have support x86, ARM, RISC-V, SW64, long arc, and Power. For the official release, in the latest version, we have support except the Power. We support them all, and the Power version will be released by the end of this month. This year, we will release the formal release for Power. So almost all of the chipset, mainstream chipset, can be found in the openEuler, we support them all. So that is diversified computing. Of course, not only the CPU, a lot of GPU, TPU, XPU, a lot of PU also work with openEuler. We support most of the AI computing power chips. Okay, of course, for all of the architecture, ARM is very, very important, or even the most important architecture for us, because when openEuler grows, the target is to support ARM. So we have a very, very wider ARM hardware support, and also we do a lot of optimization job for ARM server, and also we have very good RAS features for the ARM server, and also most of the feature is will be upstream first. So what we do, we will upstream to the kernel, the glibc, the virtualization, container, big data, AI, or something like that. But also, of course, if you the upstream, very difficult, because sometimes upstream doesn't accept very aggressive features, or there are very long time to accept the new feature or something like that. openEuler can contain those kind of feature in advance. So we are commercial, community. So we are very happy to accept those features, especially for the commercial features. So that is the way we work with the chipset. Okay, here is a very interesting part is AI. So AI is a very hot topic. I don't do the explanation in detail what the Chinese name is. Here, for AI, there are two directions. One direction is the AI for OS. The other direction is AI, OS for AI. First part is AI for OS. So our idea is, for me, I'm not an AI expert, but very easily to use AI to change OS. I think I'm not an AI developer, but I'm an AI user. So here we develop a new software, we call it EulerCopilot, but the name we may change it, may have a new name. Here, the EulerCopilot has, you can see like interface between the people and the operating system. Here, the example is, here, let me help you to analyze the NGX performance. So you can use the natural language to talk with the openEuler, and then EulerCopilot accept your language and do the analyze, use the big model to do the analyze, and then they link with different agent. For example, here is the performance tuning, right? So it will use the performance tuning agent to connect with another kind of innovation project we call it A-Tune in openEuler. So you can use the natural language to talk with openEuler, EulerCopilot, and the Copilot will link those jobs to the dedicated system. So you can see it's very easy. You can just use the language to help to have the performance tuning. Here we can get a very good result. You don't need to program. You don't need to write a script. You don't need to know very detail of the API or something like that. So that is the tuning. Here is the DevOps, another example. It's also, I think it's not easy too small, but I can do the explanation. Here is a cluster or cloud data center environment. Here you can talk with the EulerMaker when something happens, something wrong, something failure happens. You can talk with EulerMaker. What's happened? What's wrong with the system? And then the system will link with our DevOps system. Use agent to link it. The backend DevOps is AOps. Is another innovation project we have bring up. So you can say, hey, it will give you the detailed analyze and provide some kind of suggestion for you to do the maintain or isolation or fix. So this is we call it intelligence operating and management. Okay, so that is the AI we have done. For the whole system, we will release by the end of this month. So by the end of this month, we can see what it is and can make a try. Another way is OS for AI. So I don't have a page to describe because a lot of material today. I just mentioned that when we do no matter what the AI is, it should running on top of operating system. So during this way, operating system can help a lot for AI computing. For example, if you do a big training job, maybe it can spend 1 week to do the big training, right? And then during the process, if it's possible for OS to help the training to accelerate, so we have GMAM. So this kind of project will link different computing unit memory to be the memory pool to reduce the movement of the data. And then this kind of the GMAM in some scenario they can accelerate reduce the time of training 30% to 40%. It's great achievement. And also, if we can have if you want to do the AI computing very easily, so openEuler will provide a full stack, the AI stack. For example, Intel is doing the migration from their one API to openEuler, and also ARM has their stack on top of openEuler. Of course, in China we have Shengteng. The CAN and Mansball, they also collaborate with openEuler. So what about ARM? I'm not sure if ARM has also the AI stack like one API or CUDA. So if ARM have this kind of AI stack strategy, we can work together to provide a the turnkey solution for the customer. So that's also the kind of way we work with AI, OS for AI. And here is a picture that I listed for the collaborative development for full stack innovation. I mentioned innovation is a very key feature for openEuler. During the latest 4 years, we have accumulated around 500 innovation projects. In this picture, we list some part. For example, on the left, you can see the security. We have SetGear. It's a confidential computing framework. If you're familiar with the ARM, you can have the trust zone, right? The next architecture will enhance the security features. And also, if you're using Intel, we have SGS or TDX, right? So if you use those kind of facility, it's very difficult to program. You need to know a lot of details of the architecture or some the chipset. But if you use SetGear, the SetGear will have covered all of the hardware detail. You only to focus what you have done, your business, your process. So that is what SetGear has done. Here, maybe on top of it, it is a cloud native. We have CubeOS, Argo, and Rubik. For Rubik, it's kind of online and offline hybrid deployment system. You can mix the online service and the offline service. So online service, Rubik can help you to ensure the QoS. And for the offline, they can use the spare time of the CPU to do the offline job. So it will promote the usage of the data center very much. This feature has been widely adopted and deployed in a lot of Chinese internet companies. This is usually a feature to promote their usage from maybe 10 to 15 to 30 to 40, even to over 50. So this feature is very interesting. I have no time to read them one by one, but you can refer to the community to find those 500 kind of new projects, and everything is open source. And on the portal, you can download a white paper. Out of the 500 projects, we have summarized around 70 project which is mature and very interesting, very important. You can download the white paper to know what it is. It has the English version, so it's very easy to read. Okay, every time when we talk about the openEuler, I talk a lot of server and cloud, but actually openEuler also has the all scenario. We have the embedded version. Here is the embedded version, a little bit like whole picture. Also, I don't have the time to do the detailed explanation. But what I want to mention is the key feature. The first key feature, we call it MICA. What MICA is when the embedded system, especially for ARM system, the embedded chipset become powerful and powerful. We have 4-core or even 8-core embedded chipset. So those kind of system, we can divide those kind of chipset or associate in different partition. So you can run openEuler in one partition to do the ecosystem-friendly application, and then also you can port in some real kernel like a Zephyr or something like that, FreeTOS, in another partition, and then you can use this kind of partition or real-time kernel to control some very real-time job. And then we can build the message channel between the different partitions, so the real world can communicate with the non-real world, and they follow the same message format. They share the same message channel. Of course, in openEuler, we also provide a very tiny real-time kernel. We call it UniProto. Of course, you can use Zephyr or other kernel, but in openEuler, we also release a real-time kernel, which is only 20,000 lines of code, very small, very fast. So here is the embedded. The general idea is that, but it's very complicated. So if anyone get interested in the embedded, we can give more information for that. Okay, here is the very briefly introduction of our latest LTS that will be released by the end of this month. I don't read them one by one. It also will focus on AI, cloud native, and hardware collaborative. So this area. Okay, that's almost the end of openEuler. Here is the X, Reddit, YouTube, or LinkedIn. So if anyone get interested in openEuler, please refer to our portal to get more information. And of course, we encourage anyone to try it, download and use it. If any problem, welcome to feedback to community. And also, of course, for Linaro and ARM, I want to mention again that openEuler try to work with the 4-scenario ARM to finish to do all scenario solution for the industry. Okay, thank you. So let's bring something new to OS and support ARM because it's better. Okay, thank you.